Hi guys, this is Mohammad P, a tutor on Chegg.com. Today we are talking about derivative. So the limit definition of the derivative, that's the main formula or the way to find a derivative of a function. But since that's going to be really lengthy, at the beginning the students learn how to use it, but later on they don't really use that to find the derivative of each single function. So because this topic is about derivative, so we need to start with the main definition or the limit definition of the derivative. And on this lesson, I'm only going to talk about the limit definition of the derivative. Before going about the formula, so the derivative is basically represents the rate of change of the function with respect to the variable, and that graphically it represents the slope of the tangent line to the graph at a specific point. So that's a concept behind the derivative. So now in order to calculate this, if we have a function y equal f of x and we are looking for dy dx, which is basically f prime of x, that's equal to the limit of f of x plus h minus f of x over h as h approaches to 0. So this is called the limit definition of the derivative, and that's the main formula that we use to find the derivative of any function. Okay, let's start with the function example. So y equal f of x, and the f of x is equal to basically 2x plus 5, and we are finding the derivative of this function using the limit definition. So I can say f prime of x is equal to the limit of f of x plus h minus f of x all over h as h goes to 0. So f of x plus h, it means that any time that I see x in the function, I change it to x plus h. So I'm going to have limit 2 times x plus h plus 5. So that gives me the f of x plus h, then subtracting f of x, which is exactly the same function that I have 2x plus 5 all over h as h approaches to 0. So now in order to evaluate this limit, I'm going to simplify it a little bit. So I distribute the 2, so it becomes a limit of 2x plus 2h plus 5. I distribute the negative 2x minus 5 all over h as h goes to 0. So as you see, I can cancel 2x and I cancel the 5. So I have the limit of 2h over h as h goes to 0. And obviously h cancels and I get 2. So the derivative of this function is going to be 2. So let's do a little bit more complicated example. So let's consider y equal f of x equal 3 over x. And I'm looking for the derivative of this function. So f prime of x is equal to limit of f of x plus h minus f of x all over h as h goes to 0. So I need to change all the x values to x plus h for the first part. So it's the limit 3 over x plus h minus, for f of x I just copy down the 3 over x and then over x as h goes to 0. Okay. So as you see, I need to combine these two fractions together and simplify the whole thing in order to take the limit. So the common denominator between x plus h and x is the multiplication of them. So I multiply top and bottom of the first one by x and the top and bottom of the second one with the x plus h like this. So Now I have the same common denominator, so I have x times x plus h as a common denominator, and I have 3x on the top minus 3 times x plus h, like this, and the h in the denominator as h approaches to 0. So now if you notice, I can simplify the numerator a little bit more, so it's f prime of x is equal to limit of 3x, I distribute the negative 3, so it's negative 3x minus 3h all over x plus h over h as h goes to 0. So I can cancel the 3x here. I have limit of negative 3h over x plus h all over h as h goes to 0. So we have limit of, here I have the denominator 1, so I can write this as one fraction. So it's going to be negative 3h over x times x plus h times h as h goes to 0. Now I can get rid of the h, that's the zero making factor on the top and bottom. And then I have limit of negative 3 over x times x plus h as h goes to 0. Since I have already canceled the h, so I can easily plug in h equals 0 here and calculate this limit. Negative 3x x plus 0, so that gives me negative 3 over x squared. And that is basically the derivative of the function that we got. Okay, so as you see, it has a very straightforward pattern that you need to put in the formula and calculate it. So using the limit definition of the derivative to find the derivatives is very easy, but it involves with the heavy algebra sometimes, as you see. This is not a really hard problem, but compared to the first one that I did, this one has a heavier algebra. There are other functions that if you wanna use the limit definition in order to find the derivative, you're gonna face with the very hard algebra, and sometimes you need to know some extra stuff in order to take care of them. Okay, so try to do more problems with this, and I hope you all enjoyed, and I wish you the best until the next video. Have a wonderful day. Goodbye.